Hello and welcome. In this video, I want to explain machine learning from a practical and clear perspective. There is a lot of noise around the topic, and it's easy to get lost in buzzwords or complex technical terms. But my goal here is to help you understand what machine learning really is, what it does, and why it matters, especially if you are involved in cloud architecture, automation, or digital strategy. We often hear machine learning mentioned together with artificial intelligence. And that makes sense, because machine learning is one of the main building blocks of modern AI. But it's important to say upfront, machine learning is not a magic. And it's definitely not intelligence in a human sense. It's simply a way of creation software that can learn patterns from data and make predictions or decisions based on those patterns. Before you proceed, if you find this content helpful, please like and subscribe. Your support helps grow our community and signals to YouTube that this channel provides valuable information. I very appreciate your help in sharing knowledge. So, let's start from a basic idea. In traditional programming, we write rules. We tell the system exactly what to do in every situation. But in machine learning, instead of writing rules, we give the system examples, data, and ask it to learn the rules on its own. A simple example is spam detection in email. Instead of listening every spam keywords manually, we give the system thousands or maybe millions of emails marked as spam or not spam. The system analyzes the words, patterns, and structure and builds a model that can decide if a new email is likely to be spam. This process is what we call training. When the model is trained, it can start making predictions on new data. And this is the core loop of machine learning. Train on existing data, then apply that knowledge to unseen data. Machine learning is everywhere today. It helps recommend products, filter content, detect fraud, predict failures, and much more. In business, it's used to forecast sales, optimize operations, automate reports, and power smart assistants, etc., etc. If you've used Google Search, Amazon recommendations, Netflix, or LinkedIn, you've interacted with machine learning. Even behind the scenes in IT systems, machine learning helps detect anomalies in logs, predict server logs, or trigger preventive actions in monitoring platforms, etc. From a technical point of view, most machine learning models are statistical models. They use probabilities to make decisions. For example, a model might say, based on the data I've seen, this customer has, for example, 87% chance of exceeding his credit limit next month. Or this transaction looks, for example, 92% likely to be fraudulent. These are not guarantees. They are prediction based on previous learned patterns. Now, it's important to understand that machine learning is only as good as the data we give it. If we train a model on poor quality data, missing data, or maybe biased data, it will learn the wrong things. That's why data preparation, cleaning, labeling, normalizing is such a big part of any machine learning projects. But we should have data on the one hand, and we should carefully manipulate with this data and protect sensitive data on the other hand. Finding a balance between these two responsibilities sometimes can be a bit complex task. There are different types of machine learning. The most common one is called supervised learning, where we train the model using labeled data like the spam examples. There is also unsupervised learning, where the system tries to find patterns in unlabeled data. For example, grouping customers by behavior. And there is reinforcement learning, which is a bit different. The model learns through trial or error, getting better over time by adjusting based on feedbacks. This method is used in robotics, games, and some recommendation systems. So, we have different types of models, and we should choose right one in our context. I want to be very clear here. Machine learning is not creative. It's not understanding. It doesn't know what it's doing. It simply reacts to data in the way it was trained. And the data is the most important part of any machine learning model. It's powerful when used correctly, but limited by the way we frame the problem. This brings us to something important. Machine learning works best when the problem is narrow and well-defined. It doesn't work well for strange goals or open-ended problems. If we don't have enough quality data, or we are not sure that the right output is, machine learning can become unreliable or even misleading. That's why many real-life machine learning projects fail. Not because the model is bad, but because the data was wrong. Or maybe the goal wasn't clearly defined. Also, machine learning models don't improve on their own. They need retraining as data changes. A model trained on customer behavior from 3 years ago may not work well today. This is one of the main reasons businesses need monitoring, evaluation, and a plan for continuous improvement when using machine learning. Now, does this mean you need a PhD to work with machine learning? Not at all. Today, many cloud platforms like AWS, Azure, Google Cloud, etc. offer tools or even whole cloud that make machine learning much easier to use, with pre-built models, drag-and-drop interfaces, and APIs. But even with these tools, you still need to understand the basics, especially if you are responsible for architecture, security, compliance, or business outcomes. So, what is my personal view on machine learning? For me, it's one of the most useful tools we have today. But it's not intelligence. It's a way to analyze data and make predictions at scale. It's only as good as your inputs. It's only as smart as your problem is clear. But used properly, it can improve performance, reduce costs, and support better decisions in almost every area of business and IT. Thank you for watching, and see you next time.